taxes?
My picture's in, so. Sorry.
You and taxes.
A lot of them.
Oh,
It's fine.
I know you got a lot of that response.
What?
How would you not try?
Why didn't you erase down that last part?
No. I would try. I would never leave the question blank.
Yo, rest in peace, Michael Jackson.
Let it go, Suha, let it go.
I can't.
Okay, so we're gonna talk something that's pretty serious. That sometimes we're gonna get a. This is the only part in terms of calculus that we actually just started calculus. Like the way we did it on the last test. Where's Nicholas go? I got bathroom. No, that doesn't go back. So, whatever we did on the last test, they are pre-calculus. They belong to pre-calculus. They're not even calculus. So today is actually the official first day of calculus. Now, is those pre-calculus on the AP exam? Yeah, about roughly worth about, I would say probably 6 to 8 points.
6%.
Yeah, and so you need a roughly 42 points to get a 3. So if you understand everything in that perspective, that if you got 100 and you understand from inside out, then you probably have one or a few points away to get you a 3. So the next thing is derivative. Derivative is a big chapter. Now derivative is in, you're gonna have derivative and integration. They both worth around 50 points. So this is the big section. Lemon just is a pre-calculus, so you didn't cover that much. So what we're gonna do is we're gonna start by thinking about algebra 1. We're gonna introduce some idea called definition of derivative. Okay, so I'm gonna try to color code this. So definition. Of derivative. Definition of derivative. But let's go back in algebra 1. Algebra 1, we learned that how to find slope. So for example, we know how to find slope of y equal to 2x plus 4, right? So that the slope is 1, 2, 3, 4, and then 1, 2, and 1, 2. So the point is like this. My slope is 2, right? So we know this from algebra 1. But here's a problem. What if I say I want a slope of a tangent line of a parabola? And what we talked about tangent line last time, review again. Can somebody tell me what is a tangent line?
The one that goes like this.
The one that goes like,
It's the pencil on the
There's a
wall.
circle and it touches like the.
It has the stab through it.
it touched 1 point, thank you. Not touching 2 point, touch 2 point something else. I think you were not here, were you? When I stabbed the water bottle?
Yeah, I was.
Okay, so that's touching 2 points. So here we want to just say, okay, what happens if there was slope right here? Okay, what is the slope? And what is the slope if it is right here? Right, what is the slope? What is the slope of this line? So that's the things that you guys need to pay attention to, whether to understand that what is slope at all the things here, across the whole curve of the problem. So a lot of you guys will say, okay, well, the slope in the past, the rise over run doesn't really work here. But truthfully, it actually does. So what we're gonna start from pre-algebra. What do we know about pre-algebra in terms of slope on this line? Well, it's positive, but how do we, if I have those 2 points, how do we find out the slope of this line? Right, so slope in pre-algebra, right? So pre-algebra is gonna be slope, n is equal to y2 minus y1 over x2 minus x1. We know this, right? Okay, so that was a pre-algebra. But now, we're gonna use this, and we're gonna get an idea says, okay, let's start by graphing a problem. And we say we wanna find the slope at 1 point. So I'm gonna graph 1, 1, 2, 4. Okay, I wanna say, hey, what is my slope at this? But ideally that we gonna say, well, we're gonna pick some points called arbitrary points. Arbitrary is just like a random point on this graph, on the curve. I hear we're gonna say it's 1, 1, but what if we don't know that's 1, 1? We say, well, this is something else. We can assume that, we can name this point. We're gonna name this point not in terms of 1, 1, but in terms of something that's unknown, okay? Something that's unknown. So for example, I'm gonna pick this point here. So don't think about this as a 1, 1. Just think about this as the f of x. Oh, sorry, my bad. It's not f of x. This is x. Some type of x. Okay, so this is a function f of x. So this is f of x. Now, if I plug in the x into this function, what is the y value? If I plug in x into this function, what is the y value? Well, we say we don't assume this is a 1. Huh? If I plug in x into this function, so for example, this is f equal to x squared. If I plug in the x into here, we're gonna call this is actually the f of x. Right? If I plug in x, right, it's gonna get f of x. What'd you say? It's not something that's so difficult to understand. Then we're gonna pick another point somewhere along the line here. We can assume that's 1, but not, I mean, probably not 1, but it could be any point here. So when you call this next point, we're gonna have an increase of distance from this point to the next point. We're gonna call that distance from here to here, and we're gonna call that delta x. Okay, so we're gonna have this part as delta x. From one point to the other point, we're gonna just change. Now delta x is not a set number. Remember, that's still a variable. The x is a variable. It doesn't have to be 1, it could be a 2, could be a 3, could be 4. But this delta x here, that makes this part as what? What is this coordinate here? Well, what is the x value at this point?
X plus delta.
Who says that?
Nicole.
Oh, that's Marwan. Okay, good. So x plus delta x. Does that make sense? If I just write here the x plus the delta x, the next this point is x plus delta x. Are you sure we got this? Okay. So we're gonna label this is x plus delta x. Now what happened at this point? If I have this output right here, output here is gonna be what? So if I go up, right, and if I go up here, so what we call this one? Thank you. So this is gonna be f of x plus delta x. Are we lost? So basically we create 2 coordinates on top of the graph. 2 coordinates. And we're gonna draw a secant line. So the secant line is gonna be going from the secant line, so we're gonna call the secant line from this part. So I'm gonna draw it as the best I can. But we're gonna draw the secant line here. So the green line, we can call this the secant line. The secant line, are you following me?
Wait, is it the dash line?
This one,
The green.
the green.
Okay.
The green is called secant line because it goes through 2 points, right? And this coordinate, what do we call this coordinate? So we're gonna name this coordinate as another coordinate says x plus delta x, and then f of x plus delta x. Do you guys understand that x plus delta x part? That's just an input output. So I input a function, for example, if I input a 1, then it's going to be 1 squared. If I put 1 plus 2, then it's going to be 1 plus 2 parentheses squared. Does that make sense?
Yeah, can you explain the secant line thing again?
The secant line, so this is a coordinate, right? This coordinate is called, we're going to base on this point right here, and we're going to base on this point because it intersect 2 points, so it's called secant
Okay.
line. Okay? Now we're going to name this coordinate as well. What is this coordinate? It's going to be what? X comma f of x, right? So now we're gonna use something. We're gonna make the equation with slope. So can you make an equation with slope based on this 2 coordinates?
Sure.
Okay, so we're gonna call this what? The y2, and this is the y1. Would you say? And this is the x2, and this is the x1. Does that make sense? So we're gonna say m is equal to
F of x plus delta x
f of x plus delta x
minus
minus f of x
Over x plus
over what?
x plus delta x.
X plus delta x minus x. So here we're gonna write on m of secant. So m of secant line. Secant, S-E-C stands for secant. So now we're gonna simplify this. Can we simplify this? It's equal to what? F of x plus delta x minus f of x. Make sure they cannot distribute because this is an argument. You cannot distribute that in. Don't do that. So here it's gonna be x and x cancel out, so left with delta x. Are you following me so far? Okay, so that is the slope of the secant. Okay, that's the slope of secant. Now this slope of secant, but we says we want to find the slope of the tangent. Okay, let's give you the tangent line, some history about tangent line. The tangent line is, they're looking for the tangent line problem back in Descartes. Do you guys know
Descartes.
Descartes?
Yeah.
Yeah, he's a philosophy. What does he do exactly?
He came up with Cartesian coordinates and proved that existence is indubitable.
Okay. And what's his famous quote?
Oh,
I think therefore I am.
I think therefore I am. So it's all the way back in the few century ago. I don't know exactly which century. So then, yeah, he's a mathematician. He looked at how did he find out the Cartesian coordinate?
I don't know.
He was looking at spider web. He was looking at spider web. He said, "Oh, okay, I can do math with that." So he created something called Cartesian coordinate. So, and the tangent line problem exists all the way to Newton, all the way to Leibniz, with all the famous mathematicians. Okay, Descartes was the first one to say this question interests me. I really want to find the slope of this line. Okay, I really want to find the slope of this line. So and then he said, okay, well let's go do it. So right now we find the secant line first. But how do we make a secant to become tangent? Oh, that's become a problem, right? So here's the idea, is you had to apply something with what we learned before. What did we learn last chapter?
Do we multiply by some?
We don't multiply by sign, it has nothing to do with sign right now. Trust me, you'll get to sign, then it's more complicated. But what did we learn last chapter? Limits, right? So can we apply limit? So what I'm going to do is this. This green line what if I shrink this arbitrary point, the arbitrary distance to smaller, smaller and smaller and smaller and smaller and smaller and smaller? Can I do that? But what it's gonna be is that green line is gonna be going from here to here. So getting smaller, 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 smaller until they get to 1 point. Do you remember what the decimals? Okay, so basically a secant is gonna reach to that. So how do I do that to this one? How do I shrink this? How do I shorten this distance? Using mathematical function, how do I do it?
You make it radical.
No. Limit, okay, let's start with limits. But are they approaching infinity? So limit, what kind of variable you want to assign on the bottom? Delta x, okay, so delta x going to what?
Negative 0.
0, thank you. Delta x is going to 0, right? And then we're going to do the same thing of f of x plus delta x minus f of x over delta x. So therefore, it was like right here, right? You see my marker start moving. I should have drawn it more obviously, but I picked a wrong graph to do. But I'm going to do it on decimal in a second. So you're going to go in shrinking like this. Eventually going to go, this distance is going to go like this, but this the green line is going to go start like this. Eventually go like this. Does that make sense? So we're going to do it on decimal. We're going to show you more clear. My drawing is not good. So then we know that this is the slope of what? Tangent line. Not only 1 point, because on a straight line I can find slope on 1 point. But this one, if I apply this correctly, I can find the slope of every single point on the curve, which is that makes very special. Okay? So now, is this understand? Yes. Yes, that's 0 over 0, right. Therefore you have to do math, right? So because if I plug in this approach 0, then I would have f of x plus 0, which is now also known as f of x, minus f of x, which is 0. Delta x is going to 0, so it'll be 0 over 0, so that's it. Okay, so what we're going to do is I'm going to show you on a graph here. I'm going to show you in terms of,
Why do we pick 0 and not like infinity or some other variable?
which 0?
Number. Like you see how delta x approaches 0, why are we using 0 and not like infinity?
Okay, so I'm going to show you here. Can that screen see the screen or not?
Yeah.
Yeah? Okay, so you can play with it when you go home too. We can do this one. Okay, so we're gonna pick this point here. Okay, so start with the green line that I was trying to explain to you. The green line here. So see the distance here. See the x distance right here, right? See the x distance between 1 to 2. So that's the delta x. But the delta x, if we shrink to 0, that's what's going to happen to that line. I'm going to see that. I'm going to show you the projection mode. So if I drag it, right? If I drag it, right? Do you see that slope is changing? Do you see that m right here is changing from one point to the other point? And eventually, it's going to become if I get so close, it's going to be a tangent line. But if I get there, what will happen? Undefined. But before there, 2.01. So, and from the other side is 1.99 to 2.01. So the limit approach help me find the slope of this line. So we know roughly they are 2. Does that make sense?
Yes.
Okay. So you start from this when delta x is roughly 1 here. So roughly 1 from here, delta x. Then it's going to change, become a tangent line. But the tangent line, you cannot see it because you have to do math to it. Is people still lost?
Yes.
Yeah, it's H delta X.
It's H delta X, yes. The H is going from, that's why a lot of definitions are different, so let's go in here. Oh crap, you're wrong. 1 point. Let's go back. Leave. Who's lost?
A little bit.
A little bit, so let's start at 1, right? Who will say start at 1? Okay, so the H is the delta X. So the delta X right now is 2, so it's gonna go down to, so this is still a secant run, right? The delta X is shrinking. It's shrinking. And eventually it's gonna go to 0. So eventually it's gonna get you a tangent line.
Wait, how does the number on delta X correlate with like the RM value?
What?
How does the number on delta X correlate with our M value, slope?
Okay, so the delta X is the, so I hear the distance from here to this point, the X-axis.
Oh, so it's the distance.
The distance, the X, the changing of X.
That makes
So
sense.
delta X is, delta means change. The
Oh, it's like
changing
in
of X.
physics.
Yes. They kind of connect them, right? Okay, so I should stress that earlier. Does this make sense? You're still lost. Angela?
I mean, it's, I don't know. I don't know what I'm supposed to be knowing, like, out of this.
Okay, no, we're gonna get to that.
Fair point.
Yeah.
Okay, so now
Yeah.
we are gonna find a slope. It's any equation that I can plug in, I can find slope at all moments. Okay? So what we're gonna do is we're gonna apply this. And this is also known, make sure on this side, it's equal to f prime of x. Prime means derivative. And therefore the definition of derivative is gonna be f prime of x is equal to limit x delta x approach to 0 of f of x plus delta x minus f of x over delta x.
Yeah.
What?
Now say it like I'm 4.
Yeah, please.
I just repeat everything here to here.
Okay,
Yeah.
what's of that?
F prime of x equal to limit delta x approach 0 of f of x plus delta x parenthesis minus f of x over delta x
So this is the definition.
of derivative. So think about it. The definition of derivative, how important is it? Very important. Yes, Anthony?
Okay, now I was gonna ask, like, so all you did was just explain us how to get the definition.
Yes, but that's a very important that you're getting from secant to become tangent by using limits. That's pretty much the sums up. Okay.
But like, what is the significance of the f prime there?
F prime of x means the derivative of f of x. Okay, so that means I can find slope at all moments. Anytime I can find slope at the tangent line. So for example, how do we know that's 2? We don't know that's 2, but how do we find it? We're gonna show you how to do it. Can I do that?
Mr. Ed, what makes derivatives significant though? Like, what are we using?
To find slope at any time, or the rate of change. Okay, rate of change. In physics, it's going to be rate of change. You're going to study about average velocity and instantaneous velocity. Okay, so
So that is the secant line, right? So how does that also change into the tangent line?
when limit delta x approach 0, because delta x is going to change, right? So that slope is going to be changing gradually to the tangent slope, from a secant slope to tangent slope.
So is there any other instances when it would change, or is it always going to be secant?
Is what?
Like, would it always just be secant to tangent?
Yes, always secant to tangent, because that's the only way for you to get from one point to the other point. We had to make that assumption when the delta x approaches 0. So I'm going to show you what, because right now you're still kind of iffy, because I'm going to show you the algebra part of things. So we're going to start by f of x is equal to x squared. So we are going to find our idea, the first part of the goal is to find f prime of x. The second part of the goal is we're gonna say that's A, and that's B. We're gonna find what? We're gonna find the tangent line at x equal to 1. Okay, we're gonna find the tangent line at x equal to 1. So what I'm gonna do is I'm gonna apply this derivative. And we can try at x equal to -2 as well. Okay, we can try at x to -2. So what happens is I'm gonna start out by using this. I'm gonna say, hey, I'm gonna use the definition of derivative. So I'm gonna apply this. So a lot of people don't know this. If I have f of x equal to x squared, now that just means parenthesis x squared, right? That means I plug in x for x. That sounds kind of stupid, but I plug in x to get x squared. But this is the original function. But what is f of x plus delta x? That is the first part you understand. So in place that x,
Squared.
I'm going to replace as what?
X plus delta x.
X plus delta x. Thank you.
Wait, do you not square? Oh, you do, okay.
And please don't kill a puppy by distributing that 2 inside, because that's what some of you guys do, which is driving me kind of crazy. Then we know that this part is like this, so we just do the definition of derivative. So we say it's f prime of x is equal to the x plus delta x squared minus the x squared over delta x when limits delta x approach 0. Remember you did this before, Anthony?
Where'd you get the x squared?
Remember you did the exact same question?
Oh, yeah,
Yes, right?
yeah.
So that's where they come from. Yes? What happened?
So like, you know how there you had f of x equals x squared? Then why are we doing find f prime of x afterwards?
We're trying to find the slope at all moments. We're gonna show you in a second. Just let me finish, because I think you're trying to ask me a question before everything's clear out. Okay, so we're gonna plug in like this. We're gonna do math, because if I plug in delta x is 0, then it's gonna be x squared minus x squared over delta x, which is 0 over 0. So we're gonna do math. So we can use two ways. We can use something different, or we can use the difference of the square, or we can just distribute it out. So I'm gonna distribute it out because I think that makes most sense. So that's gonna be x squared plus 2x delta x plus delta x squared, and then minus x squared all over delta x. How many of you guys are lost? Why are you paying attention to me?
I'm not, I was just thinking.
Oh.
Yeah.
Okay. Yes.
I have a question. So like, what I don't understand is why do we have to like get down?
Let me finish.
Okay.
You guys are trying to ask a question, but you don't. You let me finish, and we're gonna show you
Okay.
what is f prime of x, because you gotta understand
okay.
how do we get there. Let me.
Not about that.
Yes.
Just like there, right at the beginning, when you're subtracting x squared, why do you subtract x squared?
Because that's look. Follow that formula. What's that formula? I'm gonna write down the formula again. So limits as delta x approach to 0 of f of x plus delta x minus f of x. By the way, you have to memorize this formula. So this is f prime of x. Basically, I'm applying this to here.
Oh, okay.
So I'm gonna do that. So once I did that, I'm gonna have the x squared and x squared cancel out, right? So delta x approach 0, and I'm gonna factor out that delta x. So I'm gonna get 2x plus delta x all over delta x. So delta x is gonna cancel out. So that's equal to limit delta x approach 0 at 2x plus delta x. Then delta x goes to 0, so that's equal to 2x. So that means f prime of x equal to 2x. That's pretty awesome, because that means if I want to find a slope, pick a point between, let's pick 1, because that's the first point we're talking about. We know the answer is 2, right? According to that, do we show you the answer is 2? What happens if I plug in f prime of 1? That means 2. Boom. what happened at 4? So if I say f prime at 4, then that's gonna give me what? 8. So that means at 4, comma 16, this means what? Means at x equal to 4, y value is 16, my slope is gonna be what? 8.
Oh, so then at that point, you just pick 2 points.
Yeah, I can use point slope form.
Okay.
So remember, they say, what happened to x equal to 1? X equal to 1, we want to find the equation tangent line. That's very easy. So when x equal to 1, my f prime of 1 is equal to 2, and f of 1 is equal to 1 because I'm plugging 1 into the original function. So therefore, I can use something called point slope form. Remember, this is my favorite form. That's my favorite form because all you got to do is replace the f prime of x into here. So usually it's f prime of a value. Okay, so some type of a you plug in. So in this case it's 1. So if I have 1, that's going to give me what? 2, right? And this is y minus 1 times y, x minus 1. Oh no, so y
X from the inside. Yeah.
x.
Yeah.
You're right. So this one's a y minus 1 and then x minus 1, right? So what you're going to do is pick anything here. We're going to show you the graph. We're going to show you the graph here. Okay. We're going to say, hey, x squared. Right? And we say, what's the equation of tangent line? Y equal to what? Y minus 1 equal to 2 parentheses x minus 1, right? So do you see that? That's a tangent line I want. Do you see that? Okay. What happened if it's at 2? What if the tangent line is at 2? Let's check out 2. I'm going to work out for 2. So that means I need to go find out what a y value is. What's the f of 2?
4.
F of 2 is 4, right? So it's 2 comma 4, right? What is my slope? F prime of what? 2, which is what? 2 plug into f prime of x, which is what? 4. So that means it's going to be y minus 4 equal to 4 times x minus 2. Okay, can somebody help me figure out? Type in that. Anthony? Type in another function says y minus 4 equal to x minus 2.
He's checking right there with the y minus 1. That's y2 minus 1, right?
Y minus 1.
It's just y, no.
Is that right?
Okay. So we don't know.
Okay, let's look at it. Where's that point? That's a green line, right?
Yeah.
Okay. So it's this.
It's right here. See that tangent line? Find out the slope at any time, not just only one location. If I slope at all location, that 2x is all location. This 2x means, all right, red. This 2x, f prime x. This means I can find slope at any moment, any x. If you plug in 10, that's going to be slope 10. If I plug in -5, that's going to be -10. Kind of makes sense because they're symmetries. Okay? Your job is to find this. Okay? So I'm going to create a problem for you, which is that's what's going to be your homework like. I'm going to say, hey, this is the question. Can I erase this or no?
No.
It's
Hold on.
Just
Alright.
do it on this board.
Then I have to drag it. Can you drag that to that board? So my
Yeah, watch this drop.
also, do you guys remember what's a normal line besides tangent line? What's a normal line? What is normal line?
Oh my god, it has one to lose.
Perpendicular line. Make sure normal means perpendicular, okay? So normal line, that means perpendicular line. which is opposite reciprocal. Reciprocal. Which is if we have m is equal to -2, the m perpendicular is what? Reciprocal is what? 1/2. It's like this. So I usually write down m perpendicular. So that just means normal line. So here's my question to you. I says f of x is equal to square root of x. Okay? And I want you to find, again, I want you to find f prime of x. That's the first part. That's part A. Part B, I want you to find equation of tangent line at x equal to 4. And C, I want you to find equation of normal line, which is perpendicular line, at x equal to 9. Okay? So this will be multiple part questions. You have to figure out what are those. So I want you to give you guys a try. I think you guys can do it. I think last period we have Anada, we have Isabel, we have Ben. Yes, Ben. We have David. Not David, yeah, he's supposed to sit over there. And they all get it. So let's give it a try. Let's find the f prime of x first. So that f prime of x means the slope at all time, in this case, or the rate of change at all time. So let's give it a shot. So what do you think if I plug in the x, what the x plus delta x is going to look like? And then just apply that formula, and then you're gonna find out it's probably 0/0. And then you have radical, so you should know how to do what kind of math is.
Mr. Yeh, regarding like this question here, how come, like on the first part where you do f prime 1 equals 2, f1 equals 1, you plug it in like that, but on the second one, I put f2 equals 4, f prime 2 equals 4. Why doesn't f2 equal 2?
Because 2 squared is 4.
Oh,
And this one is 2 times x.
oh, f2 is squared?
F2, 2 means I put in 2 into original function, not into the prime. So maybe it's a bad example to pick out 2. Let's pick 3. If I were to pick 3, then if I say I want to find the equation of tangent line at 3, then it's going to be f of 3, then that's going to be 3 squared, that's equal to 9, right? And then f prime of 3, prime is going to give you the slope, so it'll be 2 times 3, that's equal to 6. So it'd be y minus 9 equal to 6 times x minus 3. For the equation 10 work, because you got 3, 9, so 3, 9, that's the point. And then 3 is plug in the prime, which is 2x, which is giving you the slope, which is 6.
Okay. Why do you multiply 3 by 2?
3 by 2 is because that's my prime.
Okay,
Prime is
so-
2x. It's 2 different functions, right? One is the original equation, one is the slope of the original equations.
Okay. So once you find your f prime, you just plug the number.
Right, to get the slope.
Alright.
But you also need to plug in the original to find out what a y value, because in the point slope form, need a point and need a slope. And if you want to make sure that if you did it right, you let me know. And we're gonna give you some hard one in a second, because I probably ran out of time, then I'll do one hard example, which is 1 over x plus 2.
This is easy.
This is an easy one. This is something that's on yesterday's test. It's really similar. The one on yesterday's test, I don't remember, it was square root of x plus 1 something over something. What, you want me to check your derivative? What's your derivative? Okay, can you tell me what square root x plus square root x is? Not square root 2x. That's not simple
I
yet.
didn't say that.
You should get 1 over 2 square root x if you do it right.
1 over what?
1 over 2 square root x.
Hold on, I want to see if we can do it first.
I had no idea what
Okay, now people will do. They're plugging.
The next question, if you say that's too easy, you can pick this one.
No.
What?
Oh, it's 1 over 4. Right, because you plug in 4. And then,
And I'm gonna do this one on a,
well, it's 1 over.
So your f of x is
Let's just get.
Hold on, wait. So, once you get that, you just plug in back the 4.
I say as I think.
once you get an f prime, then you just plug in the x value, because they say at x equal to 4, plug in 4 into the prime, plug in that 4 into the original equation, because that point has to touch each other, tangent line has to touch each other. So therefore, you have to have that original xy coordinate, and then you plug in the prime to get a slope, and then you're done. And you can check your graphic calculator to see if it's right, because using point slope one is much easier. It's not f. No, it's not. Plug in the x, instead of plugging x, you're gonna plug in x plus delta x. That'd be square root of x plus delta x.
Also, all this is square.
Okay, so
Good, then we're gonna use the definition of derivative. What's the definition of derivative? It's the f of x plus delta x, which is, you already did that, minus fx, which is square root of x, over delta x, and then x equal to x.
Oh, okay, your slope is. So it's 1 over. Plug in, so your slope is.
Because for this, for x, you just plug in, you just plug this in. That's just what you just plug this in. X plus delta x, that's what we did over here too. So x is delta x,
X
and
plus
then
delta x.
for this, because x is squared over there,
Now, let's
you're
look at
trying to
this.
like make that
Now,
equal that x
it's
is equal
radical.
to x
Let's do
plus
it.
delta x, so you have to have a square there.
There we go.
That's
So can you do
f of
complicated?
x is equal to x squared.
You said this was right?
For that equation, I'll just.
It's not right.
Okay, look,
Wait, so
look, okay.
No.
So you see right here, the equation is f of x is equal to x squared. So we just want to give x plus x, delta x. So essentially for this equation.
Oh, okay,
I mean,
okay.
the bottom, you didn't write
Wait, so
the
then it
bottom.
would be like x plus delta x.
Where does bottom go?
Okay,
Square
man.
root of
I know how to do it.
blah, blah, blah.
Where's the bottom go? The bottom
Wait,
is
mine is-
here?
But
But
like,
what
You
if-
need a bottom.
No, no, no.
Okay.
What if you subtracted by?
square root of x here.
Yeah.
And then I'll plug it in here,
Wait.
or just use
no, you don't open.
Radical x.
Okay.
So you pull delta x out of this.
Okay, I got,
Oh,
okay.
I did the find out what you changed. So this is only
When you plug in
10.
0, it's gonna be 0 and 0. But I don't understand how to like, what these two zeros.
Square root of 9 is only one value. X squared equal to 9 is two
You can
values.
combine the top.
Square root of 9 is only one value.
That's what I was thinking. I'm not sure.
First, look at your definition.
So maybe it would be
Plug in
2x.
your x.
Or no, x squared, I don't even know.
You don't know.
So then I ask, and then you just do the
I don't
reciprocal.
Good.
Oh,
Keep on going. Limit delta x approaching infinity. Come on, write down.
Infinity.
Yeah. No, it's 0, sorry.
Yeah, I was about to say.
Limit delta x approaching
If you plug in
infinity.
0 for delta x, then it's just gonna be 0 over 0.
So what are you supposed to do when you have radical? What kind of math?
Oh, conjugate.
Conjugate.
Oh!
Conjugate.
Or just that square root.
So is it gonna be radical
Alright,
x plus
let's
delta
try
x
this other one.
plus
The
radical
other
x?
one's kind of hard.
I get it,
You got 2 minutes, never mind.
Okay, x plus delta.
Do it, do it, do it.
Or
Come on,
in
2 minutes
talk in your
enough.
head.
There's no one putting it right here.
So let me go over this part. Some of you guys don't get it. So what's the x delta x? If I want to do that definition derivative, so that means f prime of x equal to limit as delta x approach to 0 of fx delta x minus f of x over delta x. So that means I need to place the x plus delta x into here. So that's equal to limit delta x approach 0 of square root of x plus delta x minus square root of x over delta x. Am I going too fast? I just plug in, that's it. It's nothing special. And then when you plug in, then you multiply by the conjugate, so because, yes. So here it's going to be square root of x plus delta x plus square root of x. So if I have, this is a conjugate, so radical is going to go away. So it'll be x plus delta x minus x over delta x times by square root of x plus delta x plus square root of x. When limits delta x approach 0. So this one is going to go away, cancel out. So it'll be 1 over square root of x plus delta x plus square root of x when limit delta x approach 0. Please keep 1 over 2 square root of x, and that's your final answer. Now, how do I find the equation of tangent line? Equation of tangent line, you need to figure out, so f of x is equal to square root of x. F prime of x is equal to what? 1 over 2 square root of x. So I'm going to plug in 4 on each, because 4 is going to help me find out that's at 2. F prime of 4 is going to be what? 1 over 4. Does that make sense? So this one means this input output, right? So it's going to be 4, 2, so it'll be y minus 2 equal to 1, 4 times x minus 4. Does that make sense?
Okay, so you just plug it in.
That's it. Now, normal line is going to be opposite reciprocal. Now, if you guys want to stay, I can go over this one, because this one you probably have a little bit hard time. It's a negative 1 over parenthesis x plus 2 square. Parenthesis square. So if I want to find the normal line at 9, so it's going to be f of 9 is equal to 3. F prime of 9 is equal to 1 over 2 times 3. So that's equal to 1 over 6. Y minus y minus 9, or y minus 3 equal to 1 6 times x minus 9.
Because 1 over 2 is what he's looking for.
It's not 1 6, so it's actually negative 6. That's the normal line.
Wait, you just plugged in.
What'd you say the second one was?
Y minus 3 equal to negative 6 times x minus 9. Negative 1 over parenthesis x plus 2 parenthesis square.
How did you get the 3 and the 1 over 6?
I plug in 9 into original function. Thank you. I plug in 9 or an original function. By the way, you did pretty good on your test. I just wanted to plug in 9. Square root of 9 is 3. And then plug in 9 into the derivative to get the slope. You can try to do this one, but meanwhile I'm gonna do it on the board so you can take a picture, or you can watch a video before you go.
Oh, it was 2 times square root of 9.
Okay.
Which is
Oh, I just realized how you
So you apply whatever's happening to the x to both of these, right? And that's how you get this.
Yeah.
Wait, okay, answer me with the square root part. So 4 of x, you plug it into the original equation, which would be square root of x.
Just
And 4 prime of x would be from what you just got.
Can you take that here?
Huh?
Bring the video.
I'll bring both of them.
So you guys can try this one before you go, because the more you try here, the less work you have to do at home. So how do I find the f prime of x? That's part A. Part B is find the tangent line at x equal to 2. So again, I will always write down f prime of x equal to limit as delta x approach 0 of f of x plus delta x minus f of x over delta x. If you write it so many times, you're gonna memorize it. So what I'm gonna do is I'm gonna plug in x plus delta x in there. So the hardest part is actually this part. I'm gonna just do it on separate parts so that way you can see it. So it's actually 1 over, replace that x, it'll be x plus delta x plus 2. Then I will place that here. I will say that's equal to f prime of x is equal to 1 over x plus delta x plus 2 minus 1 over x plus 2 over delta x when limit delta x approaches 0. Do you understand that first step?
Okay.
Do you understand that first step? I just place that x because my f of x is this. I'm going to replace that x as x plus delta x. Okay? Is it shooting the whole screen or no?
Yeah, it's shooting
It's like
everything.
super close up.
Okay, so does that understand? I just replace that. Instead of 1 over x plus 2, I'm going to 1 over x plus delta x. Because of the x, I'm going to replace it as x plus delta x. Are we okay here? Now I need a common denominator because if I plug a delta x in there, it's 0, it's going to be 0 over 0. So what I need a common denominator, right? Just like before, you're doing this, you need to multiply that side by what? X plus delta x plus 2, I will say, over x plus delta x plus 2. Am I going to do fast? And I'm going to multiply that side by what?
X plus 2.
X plus 2 over x plus 2, right? So then I'm going to get what? Limit delta x approaches 0. See, I keep on writing this. So I know it's tedious, but do not FOIL the bottom. So it'll be x plus 2 times x plus delta x plus 2 on the bottom. And I'm going to keep up top the same. So it'll be x plus 2. I'm going to distribute that negative sign. This is a problem. People have problems distributing all the terms. So I'm going to drop this parenthesis here. I'm going to subtract x, subtract delta x, and then subtract 2. All over delta x. Do you see that negative signs distribute to all the terms? Now I can see that x and x cancel out, 2 and 2 cancel out. See, it's really nice that you're going to have a delta x left because the whole goal is to cancel the delta x. So that's limit as delta x approaches 0. You're going to have delta x on the top and it's going to be x plus 2 times x plus delta x plus 2 times 1 over delta x. Because this one's keep change flip. This one going to cancel. That's equal to, this one's negative delta x, yeah. So that's why you have negative 1. So it'd be limit delta x approach 0. So it'd be negative 1
They can see
over
it.
x plus 2 times x plus delta x plus 2. And then I'm just going to approach 0, so it's going to be negative 1 over x plus 2 parentheses squared. And then if I want to find a tangent line at 2, I just plug in what? I'm going to plug in 2 into the original function. So original function is like this. I'll write it down. F prime of x is equal to negative 1 over x plus 2 squared. So I'm going to plug in 2 on both. 2 to get original points. So 1 over 4, I think. Right? F prime of 2 is going to be what? Negative 1 over 2 plus 2 squared. So it'll be negative 1 over 16. So it'll be y minus 1 over 4 is equal to negative 1 over 16 times x minus what? 2, right? And that's my equation of the tangent line at this case.
So that's the final answer?
That's the final answer for the equation tangent line x equal to 2. If it's a normal line, it's going to be what? Positive 16.